In this video, we'll be discussing how to evaluate limits at infinity of radical functions. Please check out our other video on evaluating limits of radical function where we explain the concept of conjugate, how to rationalize. Now, in evaluating limit at infinity of radical function, recognize that its limit at either plus or minus infinity. The next step is you rationalize. After that, you factor out the highest power in the root, followed by identifying the dominant rate, and eventually, if need be, substitute for x in the expression. Let's put this in practice. If you are given to evaluate the limit as x approaches infinity of root x square plus 3x minus x. How do you evaluate this? Now, since it's the limit at infinity, we are going to rationalize, meaning we multiply both sides by the conjugate. Remember, this is exactly is like 1 over all over 1, right? So we are going to multiply both sides by the conjugate. We are going to have eventually the limit as x approaches infinity of root x square plus 3x minus x, multiply its conjugate, which is s square plus 3x plus x. Remember, conjugate, you just flip the sign between the terms. Now all over the conjugate, which is root x square plus 3x plus x. If you look at the top, we can rewrite it as difference of squares, because if we have a minus b, multiply a plus b, just like as we are having at the top, this can be written as a minus b square. So it can be written as difference of squares, and difference of square, this if expanded, we can have a square minus b square. Let's apply that here. This will imply that we have the limit as x approaches infinity of root x square plus 3x minus x all squared all over root x square plus 3x plus x. And if we continue to expand, so what we have at the top is x square, the root of x square plus 3x can be written as this to the power of 1 over 2, right? This is square. Now minus x all squared. So we see when we expand, this can cancel out the root. So we have only this term left and x squared. So if we rewrite that, we are going to have the limit as x approaches infinity of x squared plus 3x minus x squared all over root x squared plus 3x plus x. Now x squared minus x squared cancel out, so we are going to have the limit as x approaches infinity of 3x all over x squared plus 3x plus x. The next step is to factor out the highest power in the root in the denominator. So what we have left will be the limit as x approaches infinity of 3x all over, if we factor out x squared, we are going to have root x squared multiply 1, that will give us x squared, plus 3 multiply x squared will give us 3x squared, but we are having 3x, so what we do, we divide by 3 by x. So the term in the root is sorted. Now plus x. And if we go further to evaluating this, what we will have left will be the limit as x approaches infinity of 3x all over root x. If we, okay, let's just write it out. We have root x squared multiply root 1 plus 3x. This is what we have here, right? Plus x. So, and root x is the same thing as root x squared is the same as x, because if we have root x, it means if we have root x squared, it means x squared to the power of 1 over 2. And if we expand, we see that 2 can cancel out this 2 here, so the root is gone. We have x left. So this will give us the limit as x approaches infinity of 3x all over x multiply root 1 plus 3 over x plus, since x is common, we'll have 1, right? And we can see here s can cancel out x, so we can now do a direct substitution. As x approaches infinity, we substitute the value of x. We are going to have 3 all over root 1 plus 3 over infinity plus 1, which will give us 3 all over 3 over infinity is 0. So we have 1 plus 0, which is 1. Root 1 is 1 plus 1, which is 2. And that is our final answer. If you find this video helpful, please like, subscribe, and share. Thank you for watching.